Today's video is going to cover lesson 3.3, negative exponents. The goal today will be to convert expressions with negative exponents to positive exponents. There's really only one term today, and it's just the idea of what converting a negative exponent to a positive exponent is. This is like the rule. So we have a concrete example. We've got 1 over negative 5 to the 1 over 5 to the negative second power. If I want to write this as a positive exponent, what I'm going to do is take the base, which is, in this case is 5, and the exponent, which is 2, and move it over the fraction line. So right now it's in the denominator, or the bottom of the fraction. So I'm going to move it over the fraction line into the numerator, and in doing so, the negative in front of the exponent becomes a positive. So now 1 over 5 to the negative second power is 5 to the positive second power. So that's essentially how you convert a negative to a positive. We've got an abstract example here where the base is n, it's in the denominator, and it's being taken to a negative exponent. To convert the negative exponent to a positive, you just take the base and the exponent and you move it over the fraction line. So now it's in the numerator, the exponent is now positive. Best way to understand this lesson is just to go through a number of examples. So we have example 1, so let's say for example we've got negative 4 to the negative third power. So my first step is going to be to box the base and the negative exponent. So here the base is negative 4 because the negative is inside the parentheses. So I'm going to box the base and the exponent. In order to make the exponent positive, I've got to move it across the fraction line. And I know you're thinking, well, I don't even see a fraction line, so how can I move it across something that doesn't exist? Well, if you don't see a fraction line, that means your expression is in the numerator. So you can easily just draw a fraction line, and you could put a 1 under it, because anything divided by 1 is itself. So now we've got a fraction. In order to make it a positive exponent, I'm going to take the base and the exponent and I'm going to move it into the denominator. When I do that, I now have negative 4 to the positive third power. Notice how the negative in front of the base did not change, only the negative in front of the exponent changes. What's left in the numerator after I move it out? Simply just a 1. Now I can go ahead and simplify this. So I've got 1 over, I'm going to take negative 4 to the third power. And I get a negative 64. So if I write it as a positive expression with a positive exponent, you have what you have on the left of the equation, and then on the right of the equation is after I simplify it to an actual value. Example number 2. So let's say we've got 1 over negative 3 to the negative second power. So my first step here is going to be to box the base and the negative exponent. So the base here is negative 3 and the exponent is negative 2. Now to convert this into a positive exponent, I'm going to move it over the fraction line. So I'm going to move it into the numerator. So I can now write negative 3 to the positive second power. What takes the place of the expression I just moved? Simply just a 1. We don't need to write things over 1 because we know that negative 3 to the second power divided by 1 is just going to be negative 3 to the second power. So my expression written with a positive exponent looks like this. Now I can go ahead and simplify this. Negative 3 times negative 3. is a positive 9. Example number 3. Let's say we have negative 2 to the negative 5th power. First step, I'm going to box my base and the negative exponent. So my base here is a positive 2 because the negative is not in parentheses, so the negative is not part of the base. I'm going to go ahead and convert this into a fraction. So I'm going to draw a 1 under it. Now I can go ahead and move it across the fraction line to make it a positive. When I do that, what I have is 2 to the positive 5th power. What's in the numerator? Well, we know that we're going to replace the expression we just moved with a 1. And we've got this negative that was not a part of what we moved. So it's actually a negative 1. Now I can go ahead and simplify this expression to a single value. In the numerator we've got negative 1. And we've got to figure out what 2 to the 5th power is. 2 to the 5th power is 32. So when I simplify this expression, it equals negative 1 over 32. Example number 4. Negative 9 to the negative 3rd power. So I'm going to go ahead and box my base and the exponent. Notice how I did not box this exponent because it was not a part of what is being taken to the negative 3rd power. I can go ahead and draw a fraction line because there does not exist one. And now I can move the base and the negative exponent across the fraction line. When I do that, what I have is negative 9 to the positive 3rd power over 1, and I'm going to bring down that negative. This is going to equal negative 1 over, now I've got to figure out what negative 9 to the 3rd power is. It equals a negative 729. Now, 729 does not go into 1, it's a fraction. However, I can further simplify this because I've got a double negative. A negative divided by a negative is a positive, so my expression in the end is 1 over 729. Example number 5. Negative 1 over 3 to the negative 5th power. So here, I'm given it as a fraction. I can clearly see the fraction line. I don't need to write it over 1 because the fraction is given to me. The negative is in the denominator, so to make it a positive, I've got to move it to the numerator. I'm going to go ahead and box the base and the exponent. When I move it to the numerator, what I have is 3 to the positive 5th power. But I moved it into the numerator, which already had a negative, so I've got to make sure that I leave that negative in the numerator. We can go ahead and replace this with a 1 in the denominator, but we know that we don't need to write 1s in the denominator. So really we just have negative 3 to the 5th power. Now, the negative is not a part of the base, so when I take this 3 to the 5th power, I'm not going to take the negative with it. I'm going to multiply this negative in afterwards. This is order of operations. First, I'm going to do my exponent, and then after my exponent, I'll do my multiplication. So I'm going to multiply this answer by a negative 1 3 to the 5th power is 243, and 243 times a negative 1 equals a negative 243. Example number 6. Over a negative 4 to the negative 3rd power. I can go ahead and box the base in the exponent. The base here is 4. The negative is not in parentheses, so it is not part of the base. I can move it into the numerator. Now I have 4 to the 3rd power over, I can replace what I moved with a 1, and that negative remains in the denominator. Now I can go ahead and simplify this by taking 4 to the 3rd power and then dividing my answer by a negative 1. 4 to the 3rd power is 64, and 64 divided by a negative 1 is a negative 64. 2 more examples. Example number 7. Negative 1 over negative 6 to the negative 2nd power. I can go ahead and box the base in the negative exponent. In this case it's a negative 6. The negative is in parentheses, so it's part of the base. I'm going to move it across the fraction line, so I'll move it into the numerator. Already in the numerator is a negative 1, so I've got negative 1 times negative 6 to the positive 2nd power. Now I can go ahead and do order of operations here. So I'm going to take my exponent, and then I'll multiply it by a negative 1. Negative 6 squared is positive 36 times negative 1 equals a negative 36. If I wanted to write this as a positive exponent in its simplest form, instead of writing negative 1 times, I could have just written negative times negative 6 squared. Last example. Negative 5 to the negative 1st power. So here I can draw the fraction line because it doesn't exist. So I can put it over 1. Now I can go ahead and box the base and the exponent. I'm going to move it into the denominator. So now I have negative 5 to the positive 1st power, and that is all under 1. Now, negative 5 to the 1st power is just negative 5 over 1.